Okay, go.
Hi, good evening. I am Hemnat Chandrasekharan from FTKE. My metric number is BS08211012. And here my group mate Mohammad Shafiq. Today we are going to present about hydroelectric power station. Let me present my slide first. First, the content. Content is first introduction. Second is how to hydropower works. Third is generation power. Fourth is transmitting power. And fourth is the turbine. And fifth is the conclusion. So first of all, the introduction. Hydroelectric power. What is it? It's a form of the energy a renewable resource, and hydropower provide the 96% of the renewable energy. Other renewable resource is included the golden wave power, tidal power, and wind power, and solar power. Is hydroelectric powers do not to create electricity nor to the pollute the air, land, or water. As the power made the hydroelectric power is play an important part the development of the nation electric power industry. Both both small and large hydroelectric power is development. We are instrumental in a early expansion of the electric power industry. The next slide is the how hydropower is work. So hydropower is work is the hydroelectric power comes from water at at work in the motion. It can be seen as for a form of the solar energy as the sun power is hydrologic and cycle which give the earth is its water its hydraulic cycle and atmosphere what reach the earth's surface as participate. So some of the water is evaporations, but much of the either the percentage of the into the soil and become the runoff the water from the rain and melting snow the volatility and reach the pond and lake and reversion of the ocean where the aberration of the constantly occurring. So the this is the circulation the ground the water flow is into ocean the evaporation the cloud is the cool and cause the precipitations. So next, so generation power. This is the generation power in the energy in natural energy is become be create the destroyed and from the change in generation electricity is not new in create actually. One of from the energy is called another form the generate the electricity water is the motion. So the next is the turbine is the rotor which the converter is mechanical energy into the energy from electricity since water is the initial source of the energy. So some power plants is the rivers and streams and the canals, but for the reliable um, water supply and dams are needed. Dams store water for later release for the purpose as the irrigation, domestic and the industry use and power generation. The reserving and the much battery storing water the release the needed to the generate power. So this is the generation generator the how to the run. Okay. So next slide will be the explained by my team members.
Okay, thank you to my friend Hermanet. Okay, now it's my turn. Okay, so we talk about to transmitting the power. So how the turbine will create the power to generate our source to go to our home. Okay, so it's a simple mechanism. So when the turbine produce a kinetic energy, so it will go to the transformer. It will go first to the our generator, and then after generator, we will go to our transformers, and then we step out, and then we go to the distribution line, or we call it the grid national, and then we supply it, go to our home, our industry, and to supply to the other country also with the same frequency, which is in 50 hertz, and then we can supply within our grid. Okay. Okay, so this how the imagination or the information that I have told to you guys before. So it is the illustration how the power we get from the station and go to our home and then go to the industry. So this is how the illustration. So the power we provide from our turbine or our station will go to our main transformer, which is our substation transformer, and then go to our generator, and then our generator will provide to the main transformer inside the substation, and then we go to the CB, and then after CB we have another transformer which is at the site in the transmission line. And then after that, we'll go to the grid national by our team from transmission line. So this is how the power insertion works. Okay. So turbine. So how the turbine mechanism works. So it's a very evergreen technologies compared to our gas turbine, diesel turbine, or coal-fired turbine. So we will provide the turbine. We using the pressure inside the water. So means that the turbine is below the water dam, and then the pressure high, and then when we open the dam or we open the gate, the pressure come out from the water. We push our turbine, and then our turbine will rotate, and then we have the energy. So the energy that provide from our turbine will go to our generator, and then that's how the turbine works. Okay. Okay, this is how the illustration that I have told to you guys. So this what we call the cartwheel reaction turbine. So here is the open gate from our dam. So the pressure from here is a very high pressure. So when we pull up the gate, the pressure will push the turbine, and then we rotate the turbine, and then have a kinetic energy, and then we produce to our generator. Generator will provide our current, and then we go to the transformers, and then go to the transmission line, and then go to our inside grid national. Okay, so for the conclusion, so hydropower is important from operational standpoint as we need to ramp up time. As many combustion technology, hydropower can increase or decrease the amount of power it is supplying to the system almost instantly to meet shifting demand. With this important load flowing capability, peaking capacity, and voltage stability attribute, hydropower play a significant part in ensuring reliable electricity service and in meeting customer need in a market-driven industry. In addition, hydroelectric pump storage facility are the only significant way currently available to store electricity. So the hydropower is a very good technology. It's a very, very evergreen technology that will reduce our cost. We only use our supply from the pressure of the water dam. So we will convert to the kinetic energy, and then we produce the current compared to gas turbine, diesel turbine, and coal-fired turbine. So it is very, very good technology. So I will share to you guys about our simulation. Okay, so this simulation, okay, here is the simulation. Okay, so here is the AC voltage. So this voltage is provided from our turbine. So this illustration that we want to tell you how the current from the hydroelectric turbine we provide go to our home and our industry. So this is the illustration. Okay, so illustration here we put AC current here, transformer here, and then I put a bridge here, and then capacitor, and then for the control voltage, and then oscilloscope and multimeter. So I will run first. Okay, here, okay, I run. Okay, so here is the result. So this input and then the output that we will get. Okay, and then this oscilloscope graph how the current from our turbine for transformers, and then this how the output that we get. Okay, I think that's all from our team. Thank you for our. Thank you to let hear our presentation. Okay.
Okay, thank you.